Hello and welcome to the Inflectra and MVP webinar on testing and compliance challenges in NERC-CIP and how we can address them. And my name is Adam Sandman from Inflectra, and I'm a technical director here. And I'm going to be talking to you today with my colleague Neil Price-Jones. Neil, introduce yourself, please.
So I'm Neil Price-Jones. I have extensive experience in software testing and sometimes the implementation of automation sometime in the past. I've worked in a number of industries, including financial, telecommunications, and pension administration, and also lecture and teach in the Toronto area and for QAI. This webinar is based on the NERC-CIP implementation that we did a few years ago and subsequently have to harden now because we didn't do it at the time.
Excellent. So in today's agenda, we're going to first of all be talking about some of the challenges in testing and developing systems and software for the energy industry, particularly in utilities market. We're then going to look at the key requirements for operating in the North America's bulk electric system, the compliance requirements and the tests that go with them. We'll then talk about some of the best practices we've found when trying to address those compliance challenges in terms of using tools, technologies, processes, and best practices. And then we'll go in deep dive into the SpiraPlan tool from Inflectra, which we believe can help improve, accelerate, and ease the compliance and testing challenges that you have to deal with. And we'll be looking at some specific functionality around electronic signatures, traceability, audit, risk management, and then at the end we have time for questions. So if you have any questions, please feel free to write them in the Q&A window inside the GoToWebinar platform. You will be on mute till the end, so please write the questions in the window, and then at the end we will read them out if there are any, and read them back to the group. And with that, we'll go into the first slides. So the first thing we'll be talking about is the urgency around validation and compliance in the NERC-CIP environment. And with that, I'm going to hand over to Neil.
Okay, so any installation that's used in a power utility has to adhere to NERC-CIP guidelines. Now, in my experience, I was more involved from the software side, and this was new to us at the time, but without compliance, we could not go live with our new product. One of the other issues, of course, in almost any industry, in addition to the power utility industry, is the fact that we have a lot of new products, we upgrade products, we change the security requirements, and all of that combines to make a very complex infrastructure that needs to have its security addressed. And that is becoming a huge issue for some utilities. As a matter of fact, I just finished an article that said utilities would be a target, obviously, either from somebody who's simply doing a prank or particularly maliciously if somebody wants to cut the power to large parts of the continent. So we know they're a target, we know there are concerns, so the regulations are more likely to increase rather than decrease. But even then, no matter how many applications we add, we must ensure that the compliance is retained and that we're always in line with what is needed there and that that is auditable. If you could move the slide on to 5, Adam, please.
Yep, hold on. There we go.
So the key word here, and I think it comes in the second bullet point in that first box, is the need to ensure that all systems are compliant. And as I said with the last slide, we are introducing new systems daily. As a matter of fact, we're introducing new software to make it bulletproof right now, and we have to ensure that that is also compliant with NERC-CIP. And that is becoming a massive piece of documentation and requirements to make that happen. So we need to ensure that all the systems are compliant, and the second part of that, remain compliant. So even though we've introduced them and potentially proved that they are compliant and we're happy that they're going forward, 3 months later, something may have come up, somebody may have found a hole, somebody may have found a security breach, and we need to update them while still remaining compliant. The other aspect of this, and a key one, is the third bullet point there, the need to retain auditable proof. Even though we're ensuring compliance right now, the auditors will show up somewhere in the future, guaranteed, and they will be looking through it. And it may be, anywhere from tomorrow to several months later. And that auditable proof is needed for them, just like it was in White UK, and we need to bring it forth and ensure that it is correct. New technologies will be used as old ones get outdated. Clients will expect quick turnaround, but they still expect that compliance to be maintained. We get to move on here. So again, the first comment here, need to ensure that all systems are compliant, but some of the NERC-CIP requirements require a time-based checking. So even though you have checked it once and maybe you've been audited successfully and passed that, you may come back in 6 or 12 or 36 months and need to reprove it. There are time components in the stack of the NERC-CIP statements that say, check this every X number of months or X number of years. So not only do we have the ongoing checking and proof, which says, have we done it? Is it correct? Is it complete? We need to retain those results and then be reminded or something along the line that says 36 months from now, you need to do this again. In my past experience, stuff that has been done in the past does not get retained. We don't remember it. So we've lost it, we recreate from scratch. That is not good. The other piece, need to retain the auditable proof. We need a date, time, and place. And we're actually encountering this right now. I need to prove the IP address. I need to prove the system it's on. I need a date and a timestamp. And then all of that's got to be loaded up somewhere and retained for the auditors. And they need to trust it. And getting that through that trust piece is a huge issue with some of the auditors because they will point to it and say, prove to me that this was done at a certain time. Word again, please.
Yeah.
So I picked on just several of the more obvious NERC-CIP regulations, and this one happens to be CIP 007-6, release 5.5, and it seems like a very obvious regulation. Confirm password parameters for password-only authentication. And of course, a lot of them are now requiring 2 or multi-factor authentication, but still, when you get to the password point, you've got to have a password that fulfills certain security requirements. We can test that those passwords are enforced on existing systems. Done that, it's easy enough to do and enforce a certain format to that password and certain criteria. You run across that everywhere. The need to regression test that regularly, however, comes up because sometimes people relax it. Sometimes for testing purposes, sometimes they don't think about it when they do an upgrade. So not only do we need to regression test the existing applications for this and provide the auditable proof that it does work, we need to check new and or upgraded systems for the same adherence to this standard. And I do have a past rather odd story about this for a customer-facing system. As you're well aware that most times when you put in the wrong password 3 times, you either get 30-minute delay or you have to reset your password. That system happened to reverse the actual switch. And if you hammer down enter 3 times, you got into the system rather than stay out of it. So they had no password control at all. And 3 tries, you were in, not out. It was a customer-facing system, not a utility. Well, actually, it was a telecommunications utility. And suffice to say, no adherence to standard there.
Sounds like it was built by a harassed parent.
Possibly he was at the time. He didn't believe it when I gave him this bug. Here's another one that is coming up right now with one of my clients in particular. Patch management process used and enforced. We are patching the system right now for security purposes. We need to ensure that it's all security hardened. Obviously, this is going on to the existing servers, the existing cyber assets, and as you can well imagine, those are scattered throughout several sites because we have redundancy built into a couple of geographically dispersed sites, and it stretches across a number of very different cyber assets. So what we need to do is to document the patch management process for every applicable cyber asset, for every applicable cyber asset type, then do it, hold the proof, load it up somewhere, and retain it. So what I want to do here and what we're gradually and successfully enforcing is that we're putting a test case together into a tool to each time the cyber asset is patched, and we run it. And therefore, if we've run through the steps, that informs us we've done all the steps that are necessary for patching that cyber asset. And furthermore, we have a record of the actual steps and screenshots and or proof or logs, whatever we happen to have to gather up to prove it was done successfully. We need that information again for the auditors. And right now I'm effectively retaining that proof in a set of scattered documents and eventually loading it up into a test management tool on site. So it's happening, but it's happening in a very, very manual enforced process that requires assembling about 6 or 8 spreadsheets, screenshots, documents, and loading them all up. And then someone else is going to have to wade through that and check it. If we could avoid that type of gather and just have it all centralized, the next person who has to do this, which will have to be redone, can find that much more easily.
Very cool. Next slide.
Move. Yeah. Yes, please.
Yep.
Okay, this again, as I said, I picked on some of the more obvious ones here, and this is CIP 007-6 R3.1, deter, detect, and or prevent malicious code. Now, most of my clients who are in the high security industry, and we have some in medical, we have some in utilities, have this.
The audio is breaking up a bit, Neil. If you could just say that last part again.
But what we don't always know is the correct detection process and whether it's being maintained. So yeah, it runs every night, but is it the one we should be running, and has it been updated over the last few days? Most of them do update, but every once in a while we have run into items where it has not been updated, or the logs, the updated databases were not there, the updated logs were not retained. We don't have any proof. So what we need to do here is ensure that periodically, and that is required, to test for the ability to update it and to run it successfully. People do not always look and make sure that is done. Go ahead.
Okay.
Configuration change management and vulnerability assessments. One that we would like to avoid if we possibly could. So active vulnerability assessment of new cyber assets. I alluded to this one a little bit earlier. One of the issues, of course, is that servers get updated, other items get pulled in, networks get changed, and sometimes it's done in a hurry because something has failed and we need to upgrade it instantly. And the vulnerability assessment is sometimes put off for the necessity to get the system back up and running. So we simply do it and we don't necessarily think about checking it until later. So again, what we have done in the past and what I would like to automate here is that for each type of cyber asset, assess and document the process that carries out that vulnerability assessment. Somewhere I want that documentation so that even if we do replace a cyber asset in a huge hurry because of necessity, we can go back within a day or within a couple of days and carry out the vulnerability assessment with the use of a test case to document the steps required in that process so I know I've done them all. And please keep in mind, there's a lot of different cyber assets on these sites. I mean, I'm talking software ones, but there are a lot of hardware ones as well that are involved and tend to sit there without thought until they fail. So it tends to happen at the most inconvenient time. However, if we've had the test case audited sometime in the past as being successful, and we create these test cases to document the steps required in the process, and we run that test case, we have what we need, an auditable record of completion of the vulnerability assessment of anything new that's come in. So all it is put in the new hardware, put in the new item or whatever, run the test case, and make sure it's correct.
Next slide.
Document the results. This is obviously a carry-on from the previous slide here. One of the issues, of course, is that if you don't retain the results, there's nothing for the auditor to look at and say, what did I do or what was done in terms of that vulnerability assessment. So this gives us the history, and that would be a run of the test case or a run of a group of the test cases to ensure that the results of every vulnerability assessment is retained, and we know to which asset it applies, we know when it was done, we know how it was done, and we have all the proof there. And if they want to go back and ensure there was no potential for a breach at some point in the past, or they want to ensure that it was done within a reasonable time, all of that information is here and retained in the record. So we should be able to build what effectively is a continuum saying this has always been protected. The vulnerability assessment has always been up to date. It's always been there. And I find myself, regrettably, stitching together disparate records saying, well, we did it in this section, and we missed a few days, and we did it again, we missed a few days. And obviously those gaps are of concern to the auditors or to anybody else in the organization. Did anything come in while that was occurring? So we want that continuum effectively retained to ensure that vulnerability assessment is an ongoing process that has never been breached at any time. Go ahead.
Yeah, here we go.
One of my favorite ones. Nobody wants backup or recovery until the day it fails. And nobody ever tests recovery. So one of the issues, everybody knows the backup is running. Everybody hopes it works successfully, and nobody ever checks recovery. I cannot believe the number of people I've had who have said, oh yeah, we backed it up. Not only did they back it up locally, they actually left the drive they backed it up on top of the computer they backed it up from. So any fire or sprinkler system going off, and this was in a machine shop in this case, but I mean, same thing can occur in any other building, could not only dump your existing system, but it could dump your backup. So not only are the processes for backup and storage or information required to recover needed from a logical and software point of view, they're also needed from a hardware point of view. Where do I back up to and where is it retained so that I know it is somewhere off-site? And just, it seems so obvious, but then again, I have had the occasional sprinkler fail in the ceiling above, and they threw out all the servers after that.
Whoa.
So what I'm recommending here is for SIP 009 in this case, record the process as a test so that execution includes both whether it works and any deviations that need to be recorded to update the process. After all, new items get retained in databases. If they're not incorporated into the backup, we're missing data. And as a matter of fact, on the security hardening side, we are logging, obviously, all sorts of potential intrusions. And those need to be backed up as well, just in case somebody has to go back and say, what happened when, what was done, did we detect it, have we got it now? And if you lose that record, then you've lost your chance of doing any sort of post-mortem analysis to see what should have been changed or what should have been tightened up for that. So again, the processes that we're using here, and this is in NERC-CIP, are being recorded into a test so that the execution does include both whether it works currently and anything that needs to be changed. Retain the latest process so that we know what we have to do next time, and audit the record of changes to keep it current and retain that as well.
Absolutely. Mm-hmm. There we go. Oh, yep.
Yep, so it is a different one here. Verify successful completion of the backup process and address the failures. Again, backups run out of sight, out of mind. Somebody in a good shop will make sure it's off-site and retained for a certain period of time and labeled properly and then recycled and or dumped, depending on the case that you need. But we need to record the process to confirm successful completion of that backup. And how do we know it is successfully completed? Certainly seen lots of backups that say, well, this record was active, it couldn't be backed up, or this was in progress and could not be backed up. That does not constitute successful completion. We need some hot backups or something that will allow us and cross-checking to make sure it's all there. So successful test case completion implies the backup was successful, and the test record indicates that the last backup completed successfully. This isn't the process that you're using on a daily or hourly basis, but it's the one that we want to use for testing to make sure that it is actually working, and maybe we want to rerun this once a week or something. Go ahead. And then this one is one of the ones I mentioned that does have a particular time period in it. So the recovery plans, which is the other thing that is inherently never tested, needs to be done at least every 36 months. So we need to record the recovery test in some place where we know what has to be done, and then we have to execute that test case every 3 years at the minimum. I would recommend personally executing it about once a month, but NERC-CIP is only asking for every 3 years. Compile and retain the results so that if it's shown up for audit, or if I need to know the last time it worked properly, even from an inquiry point of view, I know what happened, I know where it happened, I know when it happened, and I know what happened at the time, so that we know whether the recovery actually worked. And this is one of the things that we skip so often. Okay, one more slide. So suffice to say, and I'm working in an agile shop that is now being pasted onto the front of a waterfall shop, which never really balances up. We have agile in the building process, but the waterfall shop to which we are delivering this, of course, has to be compliance ready. So we're generating the design, the requirements, the processes we're following for this hardening as we go along, and we're using the as-built as the proof for the final result. But the first question that comes back from the client, is this compliance ready? Where's your compliance proof? What did you gather up for this? And unfortunately, it's becoming an after-the-fact gather of the data and trying to connect it all back together from several spots to make sure it is actually compliant. And this has turned into a huge piece of work that really should have been thought of upfront and avoided by having the information we needed to gather as part of the testing, so that when they did it or when they did an upgrade, they simply said, here it is, it's already ready, we've got it, it's there and going. So Agile today, compliance tomorrow should be really rewritten as Agile today, compliance yesterday.
Well, compliance always. I mean, you always should be compliant as you're doing it.
Yes, but yesterday would have been better than today. Yeah.
That's true.
Yeah.
And now we're moving on to the next part of our today's agenda, which is the best practices in validation and compliance with the NERC-CIP. And I think it's back to you again, Neil.
Yep, I was going to talk about this, and as you may have realized, I have alluded to this a number of times already. I am having to manually glue together different artifacts, which are retained in scattered spreadsheets and Word documents and PNG files, for example, load that up to a spreadsheet, which is then going to be transferred into the test tool, which will then be evaluated by the person who's responsible for ensuring our adherence to NERC-CIP, and he will then send back and say whether or not we've been successful. This is a very, very tough process to follow. What I'd much prefer is to have the test cases in a spot where I can say, I've executed this test case, here's the proof. If you've got a problem with this, we need to change the test case, not the proof going. I want to change up front. I want to do the quality assurance thing rather than what's effectively the quality control thing. The other thing is there's 187 different controls they want proved. And as it says here, easy to miss patterns and deficiencies. It's very, very difficult to maintain 187 different controls in mind and say, but these are all the same, or parts of them are the same, and we can do these all at once without issue. So it's easy to miss patterns and deficiencies. It's easy to miss what we could do all at once rather than waiting by digging through the 187 controls. So I'd really love to create, as it says in the second bullet point, an integrated process across. Right now, one discipline would satisfy me. I wait for the others. I'm not going to do all disciplines at once. What are the requirements? Those are my 187 controls. How do I test and apply quality assurance to them? I write up a process that says, here's how I gather the information, not after. And then for the development and change management, which they do have down very, very well in this particular client. Change management is something they do have a good control over. It would be incorporated into there in terms of the capture. So we're not going back after and saying, what did we change? How did we change it? And how does that go back to the compliance requirements? So even though their change management process is very well controlled, and a lot of them are, the integration with compliance has not yet occurred. The other one, of course, what is the risk on certain of them? And certain of the controls do not apply to certain aspects of the process we're currently doing. They're just not applicable to that piece, but we have to answer why not. And I don't want to lose that after I've thought, this is not applicable, here's the reasoning, here's the proof. I want to record that somewhere and say, not going to need this going forward. If somebody comes back 3, 4, 5 years down the line and says, why wasn't this done? We have a documented statement there that says, this was not done for the following reasons. And if you have a problem with that, you can readdress it at that point. Maybe the risk has gone up and we do need to address it, but right now we don't. The other one, single source of truth with integrated traceability. A huge issue when everything is scattered like it is, and we're having a big difficulty with getting it together. But effectively what we're doing, as it says in the first one, we're manually combining it and then uploading it and then waiting for it to come back as having been passed or failed.
Next slide.
Go ahead. Yep, sorry.
No problem.
Yep. So very key here, I want one system where the source of truth is. I don't want it in 6 or 8 directories to which some people don't have access, particularly in a lockdown site. So the system is the generated spot for the truth. One other concern that they have here, and this has come up with their existing test tool, is that they don't feel it is secure. So there's a huge concern with the existing test tool, the existing way they're holding stuff, that it is not secure, and they actually don't want stuff loaded into it that might compromise the integrity of the system. So in particular, as an example that came up this morning, we're supposed to prove that IP addresses for what we're hardening are correct, but we're not supposed to load them into the system because it's not secure. So we have a bit of a dichotomy there. How do I redact the IP address, but still prove that this relates to the particular server we've got? Change the concept of requirements. Well, from being a document to being a set of data. We've kind of done that. We've put it into the system. It's become a set of requirements in the system, but at least it's something that is there to which we can apply the data, and then we can inform our activities, particularly going forward for any changes that need to be done. We can pull down what was done before and ship it in and say, this is how we proved it. The other one, ensure the system is configured to match your process. Well, the pandemic has caused an issue right now in the sense that I cannot get into the system because I cannot get a laptop because I cannot go visit the site. So we're doing a lot of transferring and sort of jury rigging. That's not something that should continue, but it certainly is current now and could come up again if something similar says, you're not allowed into the building for now because of some issue that we don't want you in there. So we need to make sure that the workflows, approvals, electronic signatures can all be done remotely, but they're still secure. Even in a process where there is a lack of physical access to the entire system, or at least to the system to which we need to load it.
I guess, have they written test cases, based on the pandemic? Has it actually resulted in new processes being drawn up?
Oh, yes. Yeah, they have had to change all their processes for approvals, for getting new machines, for welcoming people, because we're not allowed on site. Right. This is the control center, and they are very, very concerned, obviously, if you walked in the door and brought something in, you could take down the entire control center.
Right,
it can't be done. Yeah, you're not allowed to do that. So yes, all sorts of things have been relaxed in order to make it happen, but now they're going back and saying this is dangerous. Into our 8th or 10th week of when you're not supposed to go in. Yes. So key that they can sign remotely, but still have a confidence that that is you who is signing, for example, which is crucial. Yeah.
Interesting. Oh, okay. So I think, before I hand over to myself, anything else, Neil, you want to add on the challenges and best practices?
No, I think I'll hand it back to you now, Adam, if you don't mind.
No problem. Well, thanks so much, Neil. So we've been talking a lot about the challenges in terms of managing all the information, the requirements, the specifications, and the standards, and being able to prove that you've tested them, and being able to prove that you've repeatedly tested them and have the evidence and auditability that comes from that. and then obviously the traceability that when you've audited something, that it ties back to the standard it was meant to be tied back to, and that the change requests coming in are all tied to the original specs. So having that managed in a central place rather than 1,000 Word documents scattered on 1,000 drives is one of the benefits we believe that the Inflectra platform brings to the market to help make it easier for people like Neil and your clients to actually manage this information in a simple but a reliable and trusted way. And so I'm going to go through a little bit about our platform, and then we're going to be going into some information about how you can actually use it specifically to solve some of these challenges. So for those who haven't seen our platform before, we're going to be focusing primarily on our Spira test team and plan core system. That's our system for managing requirements, tests, defects, change requests. It also can provide you program and risk management. And depending on the size of your organization, if you're looking at, as Neil said, if you just want to start at the beginning and just manage your requirements and your tests and solve that business process, then Spira Test is a sufficient solution. It gives you that requirements, specs, all the standards can be managed. They manage the testing activities and the history. And when defects and issues occur, they can be tracked and tied back. Then if you need to be able to do some more project management, task management, and being able to plan out multiple teams, our Spira Team Edition gives you some planning tools and resource management tools to extend that functionality. And then if you're in a very large organization where you want to start to do risk management, you have many different programs all happening at once, and you need to track them in a large scale. SpiraPlan gives you that extended view of everything. So for today, we're going to be looking mostly at the Spira test side of the system, but again, risk management is in the SpiraPlan version, and you can slowly take one process and make it better and optimize it, and then add on others later. So let's look at SpiraPlan specifically. SpiraPlan is the enterprise tool set that lets you manage from an entire organization down to a team. And then Spira Test really is the entry level to start with one process. And if you want to look at them in different detail, there's a link in this presentation that goes to our website where we have an actual feature by feature comparison. So you can look at the 3 different editions. But if you decided to start with Spira Test, you can always graduate up without having to, without having to upgrade or change your data. It's the same system, just a different edition. So it's very easy to start small and then grow. So let's look at some of the features we have to make compliance management easier. The first thing is that all the Spira products, whichever one you start with, they come with end-to-end traceability. And that's traceability at the very least from requirements management, requirements through to test cases, to all the times the tests are executed, to any deviation or change request or defect that comes out of those tests when they fail. Also, when you do have an issue that's found, you might want to write a new test case, because one of the things you want to do is to systematize the issue that you found. So if you found the defect, maybe a vulnerability that wasn't understood, you don't just want to fix it, you also need to document how you found it so you can find it again in case it comes back or it's inadvertently reintroduced. So traceability runs in both directions, from requirements to tests to issues and change requests and back. And that's end-to-end traceability in both directions is really important. But then as you layer in things like risk management and being able to layer in code and the systems that are actually being built, do you need traceability down to the individual line of code? Do you need traceability to the risk that you're mitigating with a test? So depending on the traceability you need, you may need to have different systems configured and different parts of the tools being used, but the end-to-end traceability as it applies to your process is really important. Another huge issue is obviously data security and privacy. So we provide our platform both on-premise and available in the cloud. Many of our customers, they want the accessibility, especially now during the coronavirus, of cloud, because it means they can get their users access to it securely versus having to give them VPN access when they haven't really thought about that, doing it quickly. So quite a few customers of ours have gone to our cloud because it's secure, but it's also globally accessible when they need it. But also they may need to have the data stored in a certain place. So make sure you understand the rules. If you're dealing with healthcare data, it has to often be in a certain province or a certain country. Same thing with energy information utilities. Maybe you have to have it in Canada. Maybe it has to be in the US. Maybe it has to be in North America. Make sure you know where the data is being stored and who has access to it. And then make sure you have appropriate contracts in place. And we make that easy with our different options, both cloud and on-premise. Another really important feature of our tools is we want you to manage the data in the system. So whether that's requirements or test cases, we don't want you managing documents and uploading them. We want you to turn those requirements into data that they can then be individually looked at. And then the granularity lets you see which of those standards and which of those requirements has been tested and which ones have failed. When you're dealing with documents, it's very hard to see patterns because you're dealing with a monolithic document. So we would say, get the data you have, and then use that to generate the documentation you need to prove to someone or to document something. Don't rely on the documentation as a source of truth. Another really huge piece of functionality that we have, which is really important, is the ability to sign things. If you're going to say this requirement has been approved, this test case has been tested, and I've witnessed it and validated it, you need to sign that. And you need to be able to do that remotely, especially now, again, with the coronavirus. And anytime you're doing things securely, I mean, scanning a physical signature and sending that in, that's so easy now to, to forge. You need something that's actually a systemic electronic signature, right? So we're using data hashing, using cryptography tools to actually prove that not only did I sign this, but where was I when I signed it? What date did I sign it? What location was I logged into the system? Did I authenticate? So using tools to actually prove that the signature is valid and what it applied to. And then the other thing that's really important we find also is we call it integration across the value chain. There are people using other tools out there. Maybe you're using some other project management tools or change management systems. Inevitably, you're going to have more than one tool to manage this information. So we provide our software that can integrate with other tools. So if you're using ServiceNow, for example, as your change management tool, that's what you've set up as a company standard. SpiraPlan can integrate with that, for example. And so whatever tool you do decide to use to manage your requirements and your tests, make sure it can tie into the other things that you have to use. So you have that data transferability. So you have an end-to-end traceability, even if it's across different tools, and that's okay. Anything you want to add, Neil?
Yeah, I just wanted to comment on the workflows and electronic signatures. I mean, obviously the key point from my necessity is to have the statement, this has been agreed to in terms of NERC-CIP compliance with the gentleman who has to review it in this case. And once he's signed, I don't want it coming back. So that is absolutely crucial. They're all about the workflow and signing off. And that to me is a big gain that I'd really like to have. Because in the tool we're using, you can actually change anything you like.
Oh, really? So after the fact?
Oh yes. Yeah, if you're sufficiently high up in the chain of people who controls the tool as an admin, yeah, you can override anything you like. So,
wow. Yeah, one of the things I know we've been asked by clients is we had some clients ask us, say, our users are a bit tired. They don't want to have to rerun the test case a second time. Can't we just change the results? Because only one thing needs to be changed. And we're like, no.
Let's just overwrite this little piece here.
Yeah. Because then you lose the history that it failed. Because you wonder it failed a month ago and it passed now. Because maybe what failed a month ago resurfaces a month in the future.
Yep.
Yes.
Yeah, but this would be key because, yes, it can be changed, and that scares me. He'll not deliberately, but inadvertently say, "Oh, I don't know, I checked that one," and change it back. Right?
Or I meant to change that one, but I hit the one next to it, and I forgot that I did the wrong one. Yes. And there's no proof.
I did the wrong one. Yeah. Right. And then it's
the road to hell is paved with good intentions. It's the same thing.
Yeah, or mistakes, as the case may be.
Right. That's true. Okay. This is your slide or my slide, this one?
I think I talked about the need to integrate risk into this one.
Okay.
Understanding and managing the risk of critical systems, only in my case from the software point of view. I fortunately did not have to get involved in the towers, knowing when they would fall over in Quebec ice storms, but defining the requirements and testing for compliance. I mean, it would have been much easier had someone, when we built the system, said these are the requirements to assure NERC-CIP compliance. This is what we have to do, and this is how we did it, because then we would not be recreating the wheel right now in terms of trying to get that compliance back. And I understand where the client is coming from. We don't feel this has been done for 5 years. We don't feel this is complete. How are we going to get back to the point where if an auditor shows up at the door, we have the proof for them? And then the other one is, as you mentioned, Adam, very thoroughly, the patterns. Where's the risk coming from? What might be reoccurring to us every time that it's the same cause or maybe the same issue? It's just showing up in multiple systems and is appearing all over the place, but we don't understand it is the same risk that's coming in everywhere and don't think of a good solution for it. So that was my only kind of 2 comments here is we lack the information to help ourselves.
Is that because it's scattered over so many different documents? Each team has its own one, so that one risk is buried in 10 documents.
And it's scattered over multiple systems.
Mm-hmm.
Right? I mean, there's 6 or 8 systems in there, at least in one system alone. There's 6 or 8 components, and there's risks on every one of them, which turns, as you can well imagine, into a massive effort to address each of those risks every time. Yeah, it's right. Just there's no central spot to find it. So yeah.
Yikes. Okay, we'll move on to the next one. So now moving back into the systems. So, I mean, the key features we've been talking about and the key elements, about managing the standards, managing the tests. We'll take these each at one time. So the first thing is the requirements management, which is if you're going to be able to manage requirements, you need to be able to have it in different views and ways that people will be comfortable using. One of the things we found in our experience is if you don't give people a view that helps them do their job, they will quickly stop using the tool and start using spreadsheets and Word documents again. It becomes a natural crutch. So, for example, in SpiraPlan, we built the initial view, which is this on the top left. It's a tree structure where you can see all the requirements, you can see all the standards, you can match the test cases and see which ones have passed and failed. And the people doing QA and QE, they really love this view because it lets them understand what the gaps are, what needs to be tested. But the people who would work in the requirements every day, who wrote the documents, they find this view very hard to navigate. So we actually created another view on the top right, which is a document view, which is a live document of those requirements. And until we gave them this view, people, I think, were very hesitant to use the tool live. They really wanted to still work in their document and kind of update it. And now, once we gave them this view, they can now see the document, see the standards, see how it's written out, see all the conditions, read it, and it is a living document, but it's still discrete entities that can be tested independently of each other or together. And so you can have that multiple views to give the different audiences comfort and trust in the system. And then the bottom one is also, if you have all this information scattered, how do you find the trends? Well, having the associations and graphical views, like this mind map view we have, it lets you see all the requirements and the associations graphically, so you can find things versus it being buried in these documents. So for us, having these 3 different views of requirements has really helped people, I think, be comfortable loading the data in and using the system as a source of truth, and then finding things when they're not sure what commonalities exist. And then obviously tying in the test cases is really important. You can see here, we can give you a live view of exactly what needs to be tested. These are all the requirements. These are the tests that go with them. You can rate them by priority, how important these requirements are. So if you have critical standards that have to be maintained and tested, maybe you do those ones first. So you can even prioritize your testing activities. And then when you see this like not covered, that means you've got requirements that don't have any tests. So obviously a priority would be to figure out what tests need to be written and then add them on. And each requirement can have more than one test. So you don't have to necessarily just simply have one test. If you find that test has missed things, you can add additional tests to improve the coverage as time goes on and build out an increasingly rich and robust library of tests and validation steps. Traceability is really important, as Neil mentioned. So we can tie the requirements to test cases and test cases to requirements. It's many to many in both directions. And you can use things like, you can use search by keyword, by ID, by name, making it easy to find and link things. Again, one of the things we found is if you don't make it easy for people to do this, then they won't use the tool. They'll start going outside the tool and printing out spreadsheets again. So we've made a lot of effort to make the tool easy to use, to enter the data, and then find things and link things. So that way people spend the time to actually link the items they need to link. Otherwise, if no one's making the associations in the system, the data is not going to have that richness to help you out. The other thing we've added as well, as we found very important, is the traceability to other parts. As I mentioned earlier on, you might get a change request coming in, and that change request relates to a requirement or a defect that you just fixed. You want to write the test to reproduce it before it's released into the wild, or before you consider it truly done. So you can have links from requirements to tests to defects and backwards, but then the system will automatically, in this case, you see an implicit link, it automatically links the defect that came out of that test failure back to the source requirement. So I can go to this requirement and see, here's all the defects we've ever had against this requirement. So against this standard, maybe it's one of those SIP standards that we mentioned about, like patching. You might want to find every defect we've ever had against patching. And now you can find it in one go, even though that may have gone through 6 different test activities that are all going to be maintained here. Or you might find a bug with patching. An issue with patching is also related to an issue with password management. Maybe the password prevented the patch being applied for some reason, or vice versa. And so you can create associations between the different items. So traceability, both end-to-end and also laterally between different requirements and different change requests and different defects, is really important. Another thing we have is integrated risk management. And we found it's very interesting. Risk management for so long has been seen as a completely separate discipline. I mean, project managers will have a project management tool. They'll have some risk management spreadsheets they put together. Everyone has their own one, and of course, they're always different. And risk management is such a crucial part of managing a project, managing systems, that it's always seemed strange to me that we don't have risk management as a standard part of so many of the tools that we use. So we fixed that by adding it to SpiraPlan. And so you can have risk management defined. You can write those risks. And then as part of the risk management process, you define the mitigations, the action plans. And the thing will be is a risk, unlike an issue, may never close. It just may be mitigated and remain. So as you said, Neil, earlier on, you may have a risk that you've looked at, investigated, you determine the risk is manageable, the probability is low, the impact is low, you do some tests, you do some verification, and you're comfortable, but then the world changes, like a pandemic happens. Suddenly the risk of not having online remote access securely to a system is now big, which it wasn't. So things that you may have had in your risk register suddenly all become really important. But if you'd already written them out, if you already documented a mitigation plan, even if it was a low probability, there's a possibility you might have had at least the skeleton of something in place, or not. But at least you can say, someone said to you, why is there no plan? You can say, well, look, the probability was low, the impact was low, we assumed it was not worth spending the time, and now we learned the lesson and we'll change differently. But it gives you that ability to make, I think, a reason, that understanding as to why something was done or not done, rather than, I don't know why we didn't do it, we couldn't be bothered. That's not true. It was measured as a low priority. And then you know how to, because the problem will be not with the pandemic, but what's the 3 other things we haven't thought of in the future that we've rated as low priority, low impact. We should look at those ones now and see which ones of those are going to happen.
Well, and I think this is going to show up more and more, that you're going to go through the list and say, yeah, we as you say, we thought this was low and now it's come high. What else is related? But equally, I mean, things that came up in the past as high sometimes go low, right? The software suddenly addresses things that didn't happen. Oh, there was a high risk of this particular item, and one of the things obviously would be a vulnerability that somebody patched, and now it's gone down, you know, in your risk list because it has been patched and everybody knows how to patch it, assuming it's actually done. So risks move up and down. Having a list there at least gives you a starting point for your next project.
Right, and then we find by tying them into requirements and test cases, having them in the same tool, first of all, means you're more likely to have a project plan that's integrated, because you're going to have the time to address the risk is the same project plan as the time to implement the requirement that you have. But also, if project managers have got 6 different tools to look at, is the risk management tool dashboard the one they're looking at today? Are they looking at the schedule and the cost? Probably the schedule and the cost. If the risk management if the dashboard has both on the same dashboard and they have to see it every day, and they see that thing in the top right that says certain and catastrophic. If I saw that number 1 that's in critical and catastrophic in this case, and I go, why is that 1 there? What's that risk? If I see it every day when I'm looking at my schedule and cost, I think as a manager, I'm more likely to do it than if it's on some spreadsheet I never look at.
Yeah, anyway. Yeah, the color coding plus the fact it's in front of your face just brings it to the fore every time. And we avoid them till the end, right? In software, we put them off.
Risks are the hardest. Right, issues are easy because, you know, issue is like, it's a problem, let's go fix it. The risks that are not, especially the ones that are in the middle, that are not ultra likely, and maybe they're pretty bad but not terrible, they're the worst ones. They're the ones that they just sit there.
They just sit, you put them off, yes, because I haven't got time. A lot of time.
And no one's holding me accountable for those when other things need to be done first.
Yeah.
Right. And then another thing we do often in SpiraPlan is document management. And although I said we do discourage documents as much as possible, you know, we'd rather you take and I'll show you how you do this after we get out of the slides. We'd rather you take a requirements document and turn it into data. We'd rather you take test case and turn it into data. But the reality is we do know that people will still need to store documents somewhere. So SpiraPlan does include a document management system that's built in. It's got versioning, it's got electronic signatures, so you can sign things. It's also got the ability to easily link those documents to your requirements and your standards and your checklists and your test cases. So if you do have a diagram that maybe you need to have because it's part of a requirement, you can share it and link it to everything else in the repository. It's not buried in another shared drive somewhere. So documentation, I think, is important, but you definitely need to look at, should this be a document in the first place? Should it actually be a requirement? Should it actually be a test case? But there are things that necessarily don't fit those categories, and it's okay to have them. But if you're going to have them, let's have them in the central place. And then again, as Neil mentioned, and I think we both talked about, electronic signatures are really important. This is an example of one of the ones in SpiraPlan. When you enter the electronic signature, you have to enter your login and password. If using, again, it could be a multi-factor authentication. You have to enter the meaning of what you're actually doing. And when you hit the sign button, it actually hashes the data, stores the hash with the data. So if someone was to go back and say, you know, I don't believe you actually signed that, we can tell you when it was signed, who did it, what the meaning was, what the change was made. And if you dispute that, we have the hash to say, well, look, if you change any of these values, the hash no longer matches and it goes red. So we're able to cryptographically verify the data.
Yeah, which would be really helpful. Yeah.
Right, this is the Photoshop image that someone doctored, allegedly, somewhere.
No comment.
No comment, exactly. Oh, sorry, source code management. Not so much this is so relevant, but if you are building systems rather than just testing other people's systems, source code management is really important. I remember reading a story from the aviation sector where Boeing would reject any piece of source code change that they couldn't tie it back to a requirement or a change request or some information.
Fair enough.
Yeah. Same thing. If you're building software for any kind of embedded utility system or control system, you've got to be able to prove why did we change that line of code. And so every time you commit something, you tag it with the appropriate artifact. And most source code management systems don't let you change the history either. So if you go into Subversion or Git, whatever you're using, in most cases, once you commit to that revision and you tag it with something, it actually is immutable. So it gives you, again, an auditable change that happened. Any thoughts, Neil, on that?
Well, in my case here, particularly with NERC-CIP, we didn't invent anything. We bought and combined, right? Because there are existing systems. Now, I would have liked to be able to say to the vendors, what sort of control system do you have? Because they were making changes right up to the end when we initially installed the system. And that struck me as extremely risky. But that was obviously off-site in their location. And one of the questions I did have for them is, how are you tracking at least your bugs? And the answer was in a spreadsheet.
Oh, no. I'm surprised, actually. I'm actually surprised because I know that I would have assumed that a large utility would effectively require all their subcontractors and vendors and suppliers to have effectively something like this where they would be able to prove every change they made and what the change was for. And
I'm with you. I did not understand how we could be picking up stuff to which the control was not there. Certainly we tested it after. I mean, it's not, not like we went forward on what they said, but I was sincerely hoping that I could get by with less than I ended up doing when we initially installed the system, because no, I don't trust what you've done because you don't have proper control and I have no traceability. So that increased my workload to make it all testing at my end to make sure it worked. I mean, obviously there was integration testing, but there was also everything else because there was no way of proving what I'd received in terms of software. Yeah.
Moving on to defect issue tracking. Defects will happen, issues, change requests, all of those need to be in the system. If you're going to track them, have a tool. Obviously, SpiraPlan has this built in. If you are using other defect tracking systems like Jira or Microsoft DevOps, TFS, or Bugzilla, whatever you're using, make sure it's integrated. And the great thing with SpiraPlan is we do offer that integration service, so you can actually still have all the benefits of traceability, but still let your developer have the tool of their choice. Or in some cases, I think like Neil mentioned, you may not be the developer. You might be just queuing a commercial package or integrating commercial systems. So you can do all the defect tracking that are logged in SpiraPlan, and then you hook it up to the supplier or suppliers' different systems, and it synchronizes defects with them. So they may get the change request in their Bugzilla instance or their Jira instance. They can make the fix, it's sent back into SpiraPlan. You can verify it against the requirement in a test case, and then you can then verify that it truly is fixed. So again, if you're going to use different systems, that's fine. Just make sure they can talk to each other. And then moving on to audit and logging, a key piece is also the audit trail. Whenever you change anything, it should be auditable. We should be able to prove what was changed, who changed it, why it was changed. And we also got some new features as well on baselining, so you can even capture baselines in the system to compare what changed. But again, find out whatever your process needs from a logging and audit trail standpoint, what the retention period is, what kinds of changes. Make sure whatever tool you choose, and hopefully it's SpiraPlan, but make sure it does have the appropriate logging and retention that you need. And again, everyone's process is different. Just make sure it matches what you say you do. Another thing that's really important is, again, secure access. Whether it's cloud-based or on-premise, don't assume that everyone who has access to the system can do everything. Make sure you've got clear defined roles, clear defined permissions. And I think the principle of least access is necessary. Whatever you need to do and no more.
That, by the way, comes up in NERC-CIP directly.
Oh, really?
That's actually one of the requirements is for the least access is best access effectively. And that has to be proved, by the way. That has to be proved from a NERC-CIP point of view. Yeah.
If I make you a sysadmin, it's so much easier. You can do everything you need all the time. Yeah, that is easy. But
yeah. Well, it does make testing faster. Rather less secure, but it makes it quicker. Yeah, it is one of the aspects there. And any enhanced access has to be granted and then removed as soon as it's no longer needed.
Right.
So that's a key consideration. Yep.
Another thing we've also added recently, which I think is really important, is as people are starting to get more sophisticated, especially with cloud solutions, being able to have federated security. So for SpiraPlan, we've always had LDAP support. LDAP is this kind of the gold standard for on-premise, where every system you have connects to your directory services. So if someone is exited willingly or unwillingly from your organization, you don't want a disgruntled employee working for a power station being able to do things, even if remotely, or even on site. Maybe as opposed to being exited, you have to be able to lock them down from every system. And it's unfortunate, but it's true. And if you use something like LDAP and Active Directory, you can ensure that's just the case. And so SpiraPlan has that. Any system you use should have that. And then if you're looking at cloud, there are things like OAuth and ADFS let you do that for cloud systems as well. So you can still have data out in the cloud, but its permissions and its security can still be tied back into your internal directory stress system. So when someone is exited from an organization, they can be exited from all the cloud environments and all the on-premise environments with one single action. Versus some admin will rush around and quickly click 1,000 checkboxes everywhere. Yeah, right. Yeah.
This has come up again recently because with varying systems, obviously with varying controls, there needs to be a removal for every system. They don't all map back to AD. So
right. So where you can map them back to AD, it's always better. So for SpiraPlan internally, we do support with LDAP for on-premise, and then we now have OAuth for cloud.
Yeah, but unfortunately for our actual applications, we can't. Yeah.
And right. And then in terms of the earlier part about agile and compliant, the whole idea within SpiraPlan, the philosophy is you can be agile all the time. Your planning board, you can see everything that's being planned for each release. Your development teams, your testing teams, they can work in an agile construct, in an agile metaphor, an agile environment. But when you need to be compliant, you can also have all the documentation, everything generated that I showed you earlier on, all the reports you can have. So that way you can take all this real-time data and still generate documentation, still see the plans, still see the traceability and the audit logs. But you don't necessarily see it here every day. You can, for example, if you're allowed to, you could potentially drag a requirement or a defect or an issue from one status to another, or from one release to another, or one value to another. And when you do that, you think you're just dragging something. But behind the scenes, we're tracking that change. It's audited. It's in the audit log in the same way as if you went to a field and changed the value. It's just being done by a drag operation. And so people will often think, well, there's no audit log. I don't know what we just did. Well, actually, no, there is an audit log. You just don't see it until you click on it, and then it's there. Mm-hmm. So I think you can make things easy for a user to be nimble. And the more you do that, the more you make it easy and fluid, the more people will use the tool and not resort back to spreadsheets. But you have the controls behind the scenes. Just the iron fist and the velvet glove kind of idea. It's hidden, but it's there. And then lastly, I would just also like to mention that whenever you're going to do anything with a technology, you need to understand the processes that go with it. And so we work a lot with partners like NVP, Neil's company, to make sure that our clients, when they're using our tools, don't just install the tool and then try and use it and don't know what they're doing, especially when you're dealing with compliance and dealing in a high regulatory environment. You need to have experts who can help you out. So Neil, if you want to talk about NVP and what you can offer, that would be really great.
Yeah, so I just wanted to actually mention in relationship to this in particular, our initial role here was an application test to say, the three things we have bought here and put together going to work for what the client wanted. The NERC-CIP thing was just an added benefit. But what we do actually is assessments, consulting, coaching, management, and training, as you may have heard from the first couple of slides, for mission critical systems. So we're looking at things that need the I's dotted, the T's crossed, the audit trail there, the items that can make a difference. Some of our work consists of resolving NCRs for software shops that have run into problems and need to get their auditability or audit record clean before they can supply. And they're in the food industry, for example, or the medical industry and or the manufacturing airplane parts industry, and without sufficient requirements, or without sufficient audit clearance, they are not allowed to sell. So it's either the business or them, take your pick. But that's what we do. We really do come in and say, this is, the best practices for testing and quality assurance, and then apply them to the project at hand when there has been a dearth of process-oriented items there. Thank you.
Great, well, thank you. So we have about a couple minutes left of our runtime. So the last thing I just wanted to show was one of the things people will often wonder is, well, let's say I'm using spreadsheets today, I'm using Word documents today, how do I get the data into the tool? Because obviously that's the biggest barrier to resistance, is getting the data that I already have in all my spreadsheets and documents. And if you can't show a way to do that, people then will quickly not want to use a system, or they start resorting back to being in the spreadsheet. So one of the things we did before the demo today and before the presentation is just load some data in. So what I did, just to show how easy it is we took some of our standard requirements and some standards from NERC-CIP. Here they are. We took some of these and we put them into a spreadsheet right here. So these are the NERC-CIP standards. These are the textual versions of them, and in reality there might be a longer description. We kept it simple with a one-line version just to show you, to give you a flavor for it, but again, it could be longer. We categorize them all as types. These are all priority critical, but they could obviously be different. We just did those to simplify things. And you can also fill in other fields here if you wanted to, like you could link them to other standards that are already in the system, tie them to a component. You can have custom fields if you want to track additional attributes. We didn't do all that today, but you can certainly do that as makes sense. So these are all my requirements, and then the system will assign them a requirement number, which is a unique number they're going to have in the system. So then what I can do is go over here to my test case section, and I can put in all my tests. And again, these are the test cases. These are the tests we'll have to perform on those standards. And then I took the number from this section over here, the 305, 306, and I pasted it over here in the requirements ID section. And that way, when I import these into Spira, it's going to automatically link them for me. So I get the traceability right from day one just by doing that. So that way, if I have everything in a spreadsheet today or a Word document, I paste it into a Word or a spreadsheet template that we have, you can basically do a bulk import and then link things in one step. And so if we now go back into here to Spira, here's the requirements as they look. They all came in right here. This is basically a set of requirements. Right now they have a test coverage of gray, meaning there's one test that it's not passed or failed, it's just waiting. And you can see the priority. Go here over to my test cases, and here you'll see the different tests that we loaded in. You click on test 1. You can see the test is in the system. There it is. Test that the password parameters are enforced on existing systems. It links back to the standard, the SIP confirm password parameters for password authentication. And then we could run this step. So the only thing we need to do is add a step. So we'll just add in a step here. Just for today, I'm going to keep it simple. So it would be, check the password complexity and enter in password that should be allowed. And the expected result would be the password is accepted. And it's always important, move this out of the way, to test the negative case. So let's do a second one, which would be enter in password that is not complex enough. And the password is rejected. So we'll save that. And now what we would do in real life is we would run this. And the system will let you run it in the tool. So it's capturing information, hit next. And then you can go right here. And then the first one will be entering the password parameters and enforced. And you could put in a screenshot to show it actually happened. So it handled it. Okay. I don't have a screenshot, so I'm just going to grab a picture of the requirement screen to save time. Put that in here. Print screen. There we go. Passed. Second one, let's pretend it failed. So, oh wow, the password was accepted. Not good. Like you said, the one where you hit enter 3 times. But, so accepted. I'll put in another screenshot, and I'll put fail. And you could also log a defect if you want. I won't do that right now, so I know we're short of time. And now you hit the finish button. Great. The test case will be marked as failed. And most importantly, if you go back to the requirements page, that requirement now shows as failed. Meanwhile, let's say we were to remediate that. The problem is if you remediate that, we will then lose the history potentially. But no, not in a tool versus a document. Because if we go in here and we run it, say a week later, we fix it, we remediate it, we can go back in here and we can say, passed okay. And I won't bother screenshots, but again, imagine I was doing them to show evidence. And this one now did pass okay. You've now got passes. So you go back to your test case list and you'll see, oh, it's 2, okay, it passed, okay, great. But really importantly, if you go back to the run history, even though it has passed and it's passed on both steps, when you go to the run history, you've always got that audit trail of not only did it pass recently, but in the previous attempt or any previous attempts, it failed. So you have that history. So, and that's as important as, and this is Neil, it's as important to have that history as it is to have the actual results. It's to be able to prove not only did it fail or pass now, but what's the history. Maybe if it's passing and failing alternate times, you've got an instability issue, and that's really important to know too.
And that's a trend that is so hard to find
in spreadsheets.
From my point. Well, it's impossible to find in spreadsheets. Yeah, it's based on your memory, right?
Right.
Yeah, I think this worked. Did it work last time? Yes, but yes, taking back is horrible.
Right. And having graphs and charts can really help with your trend line. So obviously there's not enough data in this one. You can see like one pass, one fail. That would give you, minimal information. But imagine you on a project like one of these ones we have, which has got a lot of data in it. You can see that same information over time, and you'll be able to see from the history of this, the trend history, what are we seeing? So again, having graphs and charts, especially time-based, really helps you. So I think we're actually over time here, so I'm going to need to cut this off, I guess. Let's see if there's any questions before we end. We're here, and questions. I'm not seeing any questions on today's webinar, so thank you, Neil, for attending.
Thank you.
And I think we had a couple of people attend, so thank you everyone for attending who joined. And a copy of this webinar will be put on our YouTube channel, so we will be placing that and sharing it out to everyone who signed up, and those who are interested, it'll be pushed out to LinkedIn and other social channels as well. And so it's great sharing a call with you, Neil, and have a good one.
You too. Thank you very much.